Good day to you all. BEEE Basic Electrical and Electronics Engineering. Unit 5 is communication systems. In a communication system, in this video I have to discuss about a fiber optic communication systems. Okay. So one of the main limitations of communication system is the restricted information carrying capabilities. Okay. So more number of data it's not able to transmitted and received through the communication channel. It is a difficult one. Okay, so to overcome this one, we have to go for we have to move on a fiber optic communication systems. To increase the in this regard, to increase the information capacity of the channel, the bandwidth of the channel must be increased. This reduces the available spectrum space. The bandwidth will be increased, at the same time the spectrum space is reduced for in that particular communication channels. The information carrying capacities of the radio signals can be increased tremendously if carrier frequencies are used. So more carrier frequencies will be used means so more number of data will be transmitted from one station to the another stations. Okay. So today the use of microwave frequencies for communications has been greatly expanded. So microwave communication is one of the communications part. So it is also used most of the places for a communication medium. Okay. So although the microwave frequency spectrum is not totally occupied at this point, it is well used. Okay. A great deal of communication takes place by microwave signal transmitted through satellite relay stations. The microwave signals transmitted from the satellite stations. Okay, so satellites can receive and transmit thousands of telephone calls to any places on Earth, or can carry very high speed of the digital data in a microwave type of communications by the help of the satellites. Okay, so this is satellite communications. So communications by light. One way to expand communication capability further is to use light as the transmission medium. So transmission mediums, by using the light, based on the light we have to send or receive the data by using the help of the light. Okay, instead of using on electrical signals traveling over a cable or electromagnetic waves traveling through the space. The information is put on a light beam and transmitted through space or through a specific cable. Fiber optical cables will be used for transmitting or receiving the data with help of the light. Okay. So light beam communications was made more practical with the invention of the laser. The laser is special high intensity single frequency light source. The laser is having on the characteristics of high intensity and single frequency of light source. Okay, it produces a very narrow beam of brilliant light of a specific wavelength. So we can use a laser as a light communications, fiber optical cables. By using a laser beam means the data losses will reduced for in the type of communication systems. Okay, because of its having great intensity, the laser beam can penetrate atmospheric obstacles better than other type of lights. So in this type of communication we can reduce or lose the data. It's very much reduced for in fiber optical communication type. Okay. So it is also more reliable for a over long distance communication systems. Communications via light or fiber optical communication systems. Okay, highly refined fiber optic cables, a new transmission medium is now available. So is now many of the new innovations and technologies are available in that particular medium of communication system. Its great advantages is that light beams have incredible information carrying capacity. Okay. So where hundreds of telephone conversations may be transmitted simultaneously at microwave frequencies, many thousands of signals can be carried on a light beam through a fiber optic cables. So via the fiber optical cables we can carry thousands of signals simultaneously transmit or received for in that particular medium of communication system. Using multiplexing techniques similar to this used in telephone and radio systems. Fiber optic communication systems have an almost limitless capacity of information transfer. The huge amount of data will be transferred and received from one station to another station with help of the fiber optical cables or fiber optical communication mediums. Okay. So there is optical fiber constructions. The optical fiber consists of a central core and an outer cladding. The material of core has higher index of refraction as compared to cladding. So this is outer surface, this is a cladding medium. So this is single core. So light will be transmitted and received in the core medium. Okay. So the optical fibers are available either as a single fiber or as a several fiber. This is a single core or single fiber optical cables. This is a multi-core or multiple or bundled fiber optical cables. Okay. A single fiber consists of a single plated core with a protective jacket. In single fiber of fiber optical communication cables having on the single core plated for the particular cables. A bundled fiber is made up of a number of individual plated on the individual core for the particular common jackets. Okay. Materials used for the optical fibers are glass and plastics. So, which type of materials will be used in the fiber optic cores or communications? Glasses and plastics are used to made up of the fiber optical cables. Okay. There are three varieties of optical fiber available today are silica clad silicon, plastic clad silicon, plastic core with plastic cladding type of fiber optical cables will be there available in the market. Okay, glass fibers are more costly as compared to the plastic fibers. Glass fibers propagate light more efficiently as compared to the plastic. So glass type of fiber optical glass type of the optical cables will be more efficiently working as compared to the plastic type of cables. Okay, so this also used in a long transmission path. Plastic fibers are less expensive and glass type of optical cables is having more expensive. Okay, so propagations of light through fiber. Light can propagate through an optical fiber by total internal reflecting and continuous refraction. So based on the two methods, it will be communicated from one side to another side. So reflecting and refraction. Okay. So optical fibers that propagate light by total internal reflection are most widely used. Principle of total internal reflection is explained as below and shown in figure. So this is a propagations or reflection and refractions of the light for inside of the plastic or glass type of the cladded core. Okay. So these are modes of propagations. The two types of modes of propagations it's available in communication systems, fiber optical communications. The first one is a single mode and second one is a multi-mode. If there is only one path for light to take down the cable, it is aligned single mode. It is a single mode of propagation systems. Okay. So multi-mode of propagation means if there are more than one path, it is called multi-mode. So more than one path is available in the core or cable means this is a multi-mode type of propagation. Only one part of light is taken down the cable means it is a single mode of propagation systems. Okay. So single mode of propagation, the central core of the fiber is so small as compared to the multi-mode of propagation systems. Okay. In multi-mode propagation system, the central core is a larger size as compared to the single mode of propagation systems. Optical fibers can be further divided into three configurations depending upon the method of propagations. Single mode step index optical fiber and second one is a multi-mode step index and third one is a multi-mode gradient index type. Okay. So losses in optical fibers. The two types of losses will be there in optical fiber communication. The first one is attenuation losses and second one is a dispersion losses. Okay. The attenuation losses means the light will be transmitted from one side of and to another side. It will be reduce the energy of the light. This is attenuation losses. This is expressed as decibel dB. Okay. This dispersion losses are the Pulses guiding losses with result in the loss of intelligence or information. The attenuation losses means lost the energy of the light, and the dispersion losses means lost the data for on a particular medium. Okay, communication medium. So this is general diagrams of the fiber optical communication systems. So information input, voice or video is converted into the pulses. The pulses is given to the transmitter, light source transmitter. So based on the pulses, the light will be emitted from the light source transmitter. Light will be traveling through the fiber optical cables, and another end the light will be received for the photo cells or light detectors. Some amount of voltages will be given to the amplifiers and shapers, and another the same pulses, sending pulses, will be received are modulated, demodulated for the receiving station pulses. Okay, this is decoded, and original video and voice source recovered from that particular medium, communications medium. So this is a general block diagram of the fiber optical communication systems. So applications of the fiber optical communications is long distance telephone systems. It will be used in a telephone system for a long distance. Interconnect computers networks within a large building, carry control signals in airplanes and ships, secure communication systems at military bases, shipboard and aircraft communications, plant and traffic control, data acquisition and control signal communications in an industrial process control system, and also it will be used in a nuclear plant instrumentations. Okay, so these are all the applications of fiber optical communications. So these are all the details about fiber optical communication systems in communication networks. Okay, thank you so much.